All right, here we go. We're continuing to review quadratics. You guys are going to refresh your memory on today, graphing, writing, and applying quadratics. Actually, probably applying quadratics will be Friday, but definitely graphing them and writing them. So remember, there are different forms that you can have a quadratic when you're thinking about the graph, the equation is. Does anybody remember what the ways were? With quadratics, there were 3 of them.
Vertex form.
Vertex form was one. Standard form.
And
X-intercept form. Okay? So, standard form was y equals ax squared plus bx plus c or equals 0 depending on how the question is worded. That's why I have 2 equal signs there for f of x. And remember, when it was in that form, you knew automatically where the y-intercept was. It was just whatever the value of c was. The axis of symmetry was x equals negative b over 2a, and that was the only piece of information about like these models that was given to you. Okay? On your reference sheet, I think. Vertex form, y equals a, x minus h squared plus k, where h and k are the vertex of the parabola. It was called vertex form because remember, h and k is the vertex, so you always know that piece right away. And then the axis of symmetry, which is always the x-coordinate of the vertex. And lastly, x-intercept form. And you knew off gate what the x-intercepts were, and you can always find your axis of symmetry by doing the sum of your x-intercepts divided by 2. All right, so these are all the examples that we're doing today on the sheet that I just handed out, okay? They involve writing equations, graphing, you know, et cetera, et cetera. I know it's kind of hard to see, but like I said, we're going to be going through these examples together as a class, so you can rewrite them if you need to. Okay? First one. Diagram represents the function. Ooh, look at this notation. Forgot to cover when we were talking about functions, but what does that mean? F of x equals, okay? Don't forget, that notation just means f of x, okay? But we have x minus p, x minus q, which means this is in what form? X-intercept. And what's the value of a? 1. Because if it was something different, it would be a number in front, okay? So write down, remember these words basically means the answer is staring you in the face. What are the values of p and q? Negative 1/2 and 2. And it could go either way. You could have said that p was 2 and q was negative 1/2. Okay? Now it's asking us to find the x-coordinate of c, which is the minimum value. So technically your vertex, the x-coordinate of your vertex. Axis of symmetry. So what we do?
Add p divided by 2.
Yep, add p plus q divided by 2. So what's a negative half plus 2? 1 and 1/2 or 3 over 2. So what's 3 over 2 divided by 2? Say again? 3 over 4. Remember, you have to keep, change, flip. So the answer is 3 over 4. It's only asking for the x-coordinate, not the y. So you gotta be careful. It's 4 marks. This is like a question 1 on a paper 1. Okay? The easiest question of the whole test is question 1. Alright? Question 3?
It's gonna be question 3.
What?
I'm scared.
You ready?
Yeah.
Alright. Here we go. The next one, it says express f of x, x squared minus 6x plus 14 in that form where h and k are to be determined, and then hence or otherwise write down the coordinates of the vertex. Why does it say hence or otherwise?
Because the first question will answer the second question.
The first question will basically answer your second question. Hence, remember, hence means use your answer previously, or otherwise means use other methods to determine what are the coordinates of your vertex. But what form is this?
Vertex form.
So you're going to have your vertex there. All right? I'm going to do this one with you because this is a review of completing the square. Okay? Yes. There are other ways that you could find the vertex and kind of just plug in, especially since A is 1. Let's review completing the square with everything on the same side. Okay? Remember, when you're completing the square with everything on the same side, whatever you get when you take half of being squared, you subtract it from the back end. Okay? Does that look familiar? It's A1. So now we can take half of B. -3 and squared. So I'm going to add 9 on the inside, but I'm going to subtract 9 on the outside. So then this can factor into a perfect square trinomial. What's on the inside? X minus 3 squared. And then on the outside? Plus 5. So then there's your answer to part A, written in vertex form. What's your vertex? 3, 5. Remember, in vertex form, it's always the opposite of X and then comma. Well, opposite of H and then comma K. Questions? Coming back? All right. You good? Coming back? Okay. All right. This one. All right. That's what I'm doing with you guys. And then we're gonna go like one by one. I'm gonna let you guys go. All right. Diagram shows the graph of the equation y equals x squared plus px plus q, and it cuts the x-axis at -2 and +3, and you're asked to find the value of those variables. Okay. Any suggestions? Elijah?
Once you get, like, put it in, like, use the coordinates to get your x-intercept form, and, like, transfer that to standard form?
You sure can. You can write this in x-intercept form first, and then FOIL it out to get into standard form. Okay? So remember, x-intercept form is x minus p, x minus q with the a in front, but what's a?
-2.
No.
Oh,
1. So, you don't have to worry about a coefficient out there. It would right here and right here. Doesn't matter what form it's in, they're always going to be the same. So this is going to be x plus 2 and then x minus 3. So then all we have to do is FOIL. It's going to be x squared minus x minus 6. So what's the value of p? -1 and q? Plus, remember, q would represent the y-intercept when it's in standard form, and you already knew that's where it crossed the y-axis.
Wow.
1 x-intercept, 1 vertex, 1 standard I did with you guys. Okay? Yes.
Okay, so would they always be like kind of like that? I mean, because you were able to find Q first before P.
Yeah, I could have found q first before p. Yeah.
Okay.
And did it a different way. Another way I could have done it was, since, like I said, you already knew what q was, so you could have used another point on your quadratic. You could use another point and plugged in. So this is y equals. I could have plugged in 0 for y and then 3 for x, and then solve for p that way. That's another way I could have done it. Okay? So then that'll give me 3 plus 3p, subtract 3, divide by 3, and p was -1. Get the same thing. That's another way you can do it.
Is there gonna be any questions where, like, find a, and they don't give it to us, or is that just?
Possibly, but the same way that I just found p by using another point is the same way you could find a. So remember, you use any point on the quadratic to find any variables that you're missing. All right, I want you guys to do this one on your own. It's worth 6 marks. So essentially, I will give you 6 minutes, but I think I'm gonna give you 4. All right.
Yay!
Okay. So Consider this function. Express f of x in the form, as you see there, where a, p, and q are something, something. What does that mean? Where they're integers. Integers are whole numbers, positive or negative. Okay? How do I do this for a? How did you do this for a? Complete the square.
Oh, thought finding the vertex.
Either way would work. You could complete the square, or you could have found the vertex and then plugged in, because again, the a in standard form is going to be the a in vertex form no matter what. Okay? So you could have done it either way. Let's practice completing the square though on the same side. We should still end up with the same answer though. So when there's a number involved in the front, okay, you want to factor that out of only the first two terms. Only the first two terms. You still take half of b and you square it. What's half of negative 4? Squared 4. A 4 goes here. But because you figured out that 2 on the outside, you got to multiply it in and put it in the other box. So this should be a 8. Yeah, that number on the outside gets multiplied by this, and that's what goes into that box. So then when you factor it, or you simplify it, becomes x minus 2 squared with the 2 on the outside, minus 3. And that's vertex form. Did you guys get 2, negative 3 for the vertex?
Yeah.
Now you do.
So I think you got it wrong.
Yeah.
Yeah, be careful.
Wait, so okay, so I got my express form as 2x minus 2 squared, and then I figured if you wanted to take out a 2, you would also have to square that.
2x minus 2 squared, so the 2x is on the inside.
Yeah.
Okay, and that's where you run into the issue. You don't take that out, so then that way when you're trying to get into vertex, because you don't even have y value, you would tend to have your y as a 0.
So what sign is your mom picking you up?
Oh my goodness, I am recording. What's the minimum value of f of x?
-3.
Negative 3. This is a quadratic that opens what way? Up. So the lowest point is going to be the y coordinate of the vertex, which is negative 3. So this is your answer to A. This is your answer to B. And let's do the next one. In 4 minutes. This one, you got to write down HK. Pretty straightforward, right?
Yep.
What was H?
3.
And K? Gotta let them write down problems. Those are give me problems. I heard you back there. Try to be smart. Now you have to find or show that A is 2. Remember, show problems. You get your points by showing the work. So, how do I show that A equals 2? Plug what in?
X and Y.
Plug in 5 and 9 for X and Y, and I also gotta plug in
2 for A.
3 and 1 for H and K.
Oh wait.
I cannot plug 2 in because I'm using the answer. Okay? Remember, show problems are basically like, you know what the answer is, now get to that point. So when I plug in 9 for Y, 5 for X, 3 for H, and 1 for K. I got everything right, correct?
Yeah.
Okay, so then this turns into A negative 2 squared plus 1. This turns into 4A plus 1. This becomes 8 equals 4A. So then A is 2.
But wouldn't first show farm, wouldn't you have to like show that you subtracted 1? Like, wouldn't you have to put the little minus 1 on both sides and then divide 4 on both sides, or would they just accept what you did?
This be good. Now we have to show that that's the equation that can be written in that format. How do I show this? Plug in what?
Your A,
Plug in my A,
your H,
my H, and my K, and do what?
Foil that.
Foil it to standard form.
Foil, distribute, and add. And now just in case if you didn't show B right, you could have still gotten C right because you had the values A, you know, I don't know how you could get there. Don't take this and then complete the square, okay? Don't go backwards. All right? Don't go backwards. We're good? Here's the next one. Ooh, this is a good one. 4 minutes.
Crossing fingers.
Here we go. Stop. Oh, you got it.
Leave a like and subscribe.
F of x equals 2k x squared minus 4k x plus 1. K does not equal 0. And then we are told that it has 2 equal roots. 2 equal roots means what?
That it's
It's
greater
so equals
than the thing is greater than 0.
It's a double root, so the something equals 0. What's the something? Discriminant. So you actually had to take b squared minus 4ac and set it equal to 0. If it was greater, that means it would be 2 distinct roots. What's b? Negative 4k. So I square that. What's a? 2k and c? 1. So when I work this out, it's going to give me 16k squared minus 8k equals 0. So I have to what? Factor out of 8k. And then solve. K equals what? And k equals 1/2. Now it says the line y equals p intersects the graph of f of x. Find all possible values of p. So it's basically saying, okay, you got this quadratic that's pointing up, and then there's a line that's intersecting the graph, and you're trying to figure out what are the values of p that can intersect this graph. That's basically what it's saying. So you have all these lines. You're trying to figure out what are all the possible values of p. Yes?
It's in the problem it says k can't equal 0, so it's only k equals 1.
Good looking. I didn't read that. Yeah, be careful. It does say k does not equal 0, so it's only k equals 1/2. So you're trying to figure out all the possible values of p to which it intersects the graph. And you'll know what p is because you're looking for the line that hits the quadratic at exactly that one point. You're looking for y equals this particular line, aka the y coordinate of your vertex. Because whatever that value is, it's going to be all the values that are greater than that. Okay? So k equals 1/2. What is my equation for f? Because I plug in 1/2 in for k. So then the vertex of this is going to be what? Let's not complete the square. Let's do it axis of symmetry. How do I define the axis of symmetry? Negative b over 2a. What's b? So a minus a negative 2 over 2a. A is the what value?
1.
So this is 2 over 2. So the x coordinate is 1. How do I find the y coordinate? Plug it in. Plug it into what? The original equation. So that's going to be 1 squared minus 2 times 1 plus 1, which is 0. So p has to be greater than 0. Could it equal 0?
Can't you do that without like doing all of that math? Because if it has like 2 equal roots, then it has only 1 root, so 1 like x-intercept.
Right.
And it's positive, so it's gonna be like
That's true. That is true. I didn't think about that.
okay, so like if it has 2 equal roots, it means that like it's gonna look like this basically. So there's only gonna be like 1 point in which it's intersecting the x-axis. So like, and you know it's positive, so you know that the only thing it can go up from.
Yeah. Double roots touch the x-axis, so what she said is correct, and I didn't even think about that. But double roots, yes, they will always touch the x-axis. So if you can figure out what that x-intercept is, then you know automatically what that y value is going to be. All right? Okay. I'm going to give you guys, flip over on the back. I'm going to give you, what's that, 6 problems? I'm going to give you 20 minutes, okay, to do these 6 problems. And then we'll check them. You guys get that?
Yes.
Then the vertex would be 3, negative 13. If the equation of the axis of symmetry, remember, it has to be an equation which is x equals 3. Did you have x equals?
Yes.
Good. The y-intercept, I'm going to go ahead and plug in, bless you, 0 for x. Did you get 5? You could also put 0, 5.
Does that mean I have to put a period or can you just write 5?
Either or.
Okay. Because I always put like y and then int equals 5.
Just be careful. It says find the y-intercept. If it says what's the point where it crosses the y-axis, then you want to make sure you include a point. You gotta be careful. The x-intercept can be written in that form that looks very much like quadratic formula. Question?
So you wouldn't get points off for not writing the full coordinates?
Not in this particular problem, because it's actually defined that the y-intercept, so you didn't necessarily have to include the 0, 5. Yes.
So this is going back to part A.
Yeah.
But I put, well, okay, well, I guess technically B. I put 3, 13, but I only did that because above that in part A it says minus K instead of plus K.
I see what you're saying.
So would that still be negative 13, or would it be?
It'd still be negative 13 because essentially this is that is that value there, and so if anything, this would be that indication that it should have been a minus versus a plus. So I think that, or it could have been a typo on their part, from whatever that year was. But it was a negative 13. So then x-intercepts negative b plus or minus the square root of b squared minus 4 ac all over 2a. That gives you 12 plus or minus 20, 40, 104 over 4. And so you could have said that P was 12, Q was 104, and R was 4. You could have done it that way. However, 104 is reducible. Not reducible, simplifiable. What does 104 reduce down to be?
Wait, 2 to the square root of 26.
2 square root of 26?
Yes, ma'am.
So this will give you 12 plus or minus 2 square root 26 over 4. This can reduce. So then if I divide everything by 2, this gives me 6 plus or minus the square root of 26 over 2. So you could have said that P was 6, Q was 26, and R was 2. Either one would have been acceptable if you had took it to that next step. Let's take a problem. Questions? What is going on? Back there. Here we go. This one, write down the values M and P. They represent your vertex, and it told you that the vertex was at M2. Since this serves as the axis of symmetry, what's halfway between 1 and 5? So M was 3, P was what? 2. Then you had to find the value of D by using the vertex and plugging it in to the vertex form. So 2 equals D, 3 minus 3 squared plus 2. That would have.
Oh, wow. Wait, 0 is
I plugged it.
Oh no, I'm sorry, I don't plug in the vertex. I can't use the vertex and the vertex formula. That was my mistake. I'm going to use a point. Let's use that one. So then that is 0 equals D 1 minus 3 squared plus 2. This gives me 4D plus 2. Negative 2 equals 4D, so D is negative 1/2. You guys get that?
I got negative 1.
Because you gotta subtract over the 2.
Oh, yeah.
Questions on either of these? And number 3, similar to the one that we did together, it says find the value of k when it's exactly one solution, which means the something, something, something. The discriminant is equal to 0. B is 3, A is k, and C is 1. So that's 9 minus 4k equals 0. Subtract 9 from both sides, divide by 4, and that's your value of k. Questions? Okay. This one here, it gave it a standard form. You had to find both x-intercepts. The easiest thing to do would have been to, what is it, factor? So what are my x-intercepts? 2 and negative 1. You could have said 2 and negative 1. Either of those would have been acceptable. The x-coordinate of your vertex is just the halfway point between 2 and negative 1, which is what? 1/2. And you get that again by adding your x-intercepts and dividing by 2. Questions? How's it going so far?
Good.
Second to last one. You had to write it down in that particular form. So that would have been negative 10, x plus 4, x minus 6. You could have had the x minus 6 first and then the plus 4 second. Doesn't matter. Then you had to find another expression in that particular form. So you had to find the vertex. Easiest way to do that. The x-coordinate of the vertex is 1. So it's the halfway point between negative 4 and 6, correct? Okay? And I'm going to plug in 1 into the x-intercept form, so that's 5. That's negative 5. So 250. So you could have also distributed, completed the square. Now we have to show that it can also be written in that form, so that means that we need to FOIL. Distribute, just like that other problem. Combine. Rewrite. I hate this pen. I'm about to break the screen. A stylus doesn't work on it though. Questions? Talk to me. How do you feel?
How'd you get, okay, so when you like would distribute from A to like solve B, how would you get 250 as your A?
Well, if I distribute it?
Yeah, if you like distributed the x plus 4 and x minus 6 part, it's like, I don't know.
Well, if you decide to FOIL and distribute, you could have done negative b over 2a, found the x coordinate and plugged it in. You could have completed the square. So if you didn't get 250, that might have meant that somewhere along the way your math got messed up.
We got, I got 25.
So there, it has a.
I know. So
You might have forgot about the 10 on the outside, because if you got 25, it was 250. You probably forgot about the 10 on the outside.
because I figured that how much is on the outside and there was like a double parentheses.
I went to the
I didn't
between the square
double
and back to
parentheses.
B.
I have to go back and double check your work to see exactly what happened.
Actually, that was probably mistakes. I probably should have distributed.
This one, it was a combination between functions and this. When you write it in vertex form, what you get for vertex form?
X minus 3
Plus 4? So then when you find the inverse of it, remember inverse you have to do what? Switch x and y. And then what? Solve for y. So I'm going to subtract 4 from both sides and then take the square root. Now here, you could do your plus or minus. Here you could have done your plus or minus. And then add 3 over. So the inverse would be 3 plus or minus the square root of x minus 4. I should probably just do the positive since this is your domain right here. I have to go back and double check the key. And then what's going to be the domain of the inverse?
Bracket 4, infinity.
Do you guys agree?
Yeah.
Questions. Questions. Thank you for listening.